So we're looking at question 8 now. A curve has parametric equations x equals t over 1 plus t cubed and y equals t squared over 1 plus t to the power 3, where t does not equal -1. And it says in this question you must show your detailed reasoning. And also it says determine the gradient of the curve when you're doing that. And what I'm doing now is I'm just looking through the formula sheet to see if they give me any help with the formula, and they do. They give me the quotient rule, which is handy because if I forget things in a state of panic, I know where it is. Why do I need the quotient rule? Well, because I want the gradient, which is dy dx. So I need to differentiate t with respect to y and t with respect to x. And to do that, because these are fractions, I need the quotient rule for that. So let's first of all do the x dt. So that one there, let's just write this equation out so you can see it if the screen is too small for you. So I need to differentiate that. So the quotient rule, you might even want to write out the quotient rule if you want, but remember where it is. There it is. It's a nice one. So here along the bottom I have v squared, and then it's the v at the top here times by the differential of t, which is 1, and then it is taking away, and that's why the order is important. I do my u, which is t, and then I differentiate that. That one becomes nothing, so it becomes 3t squared. So now let's tidy all that up. 1 t cubed minus 3t cubed, so it's 1 minus 2t cubed, and I'm going to leave just that at the bottom like that. So that's my dx dt. Now my dy dt, and very similar idea. My y value, let's put it here so you can see it, uv. So again, creature of habit, in the times of stress it's good to have. My v goes to the top there, so it's 1 plus, but this time I'm differentiating t squared, which is 2t, minus, now t squared stays there, and differentiate that bracket, which becomes 3t squared again. This is a bit more laborious, so let me copy it all out. I get 2t. Be careful you don't rush things. I'm in the real habit of always rushing stuff, so just be careful. You take your time, and as they say, think a lot. Think of everything you got. So that's 2t. 2t to the 4 minus 3t to the 4 is minus t to the 4 all over 1 plus t to the 3 squared. So good so far. Now I want the gradient, which is dy dt. And I know this is just very simply put. If I put that a, b, and b is the same there, so let's call that c. I want dy dx, so I want cb over ab. And as you can see, the b's cancel, so it's c over a. So it's going to be 2t minus t to the 4 all over 1 minus 2t to the 3. And it says a gradient when t equals 1. So that means it's 2 minus 1 all over 1 minus 2, which is 1 over minus 1 minus 1. So I get the gradient of minus 1. And then it asks, verify that the Cartesian equation of the curve x cubed, so this is part 2, x cubed plus y cubed equals xy. So I need to cube that one there, so it's t cubed over 1 plus t cubed to the cube plus t squared cubed is t to the 6. Again, you just have to be really careful that you don't rush things. So on my left hand side here, I'm going to get, when I add, I have common denominators, so that's nice and easy. I get this all over Let's just tidy that up. I can take t to the 3 out, so I'm left with 1 minus t to the 3, and that can cancel out. So it is important to tidy things up, so that let's put it here, t cubed, that cancels out all over 1 plus t to the 3 squared. Now let's consider the right hand side. Right hand side is xy, so it's t over 1 plus t squared multiplied by t squared over 1 plus t cubed, which equals, that times that does equal that. It's the same. And because they equal the same, boom, nicely done. Hope that's helped.